The next topic of discussion is going to be VLAN trunking protocol. Very unfortunately named because this protocol has nothing to do with bringing up trunks. So the two protocols that we covered that have to do with trunking, the trunking protocols, are ISL, interswitch link, and 802.1q. VLAN trunking protocol is thus named because it only works over trunk links, or it only works over trunked ports. Hence it's called VLAN trunking protocol, but it has nothing to do with bringing up a trunk. Now, before I go into detail with VTP, let's go over generally what it does. Let's say at your work you have 50 switches, and your boss tells you to go configure VLAN 10, 20, 30, 40, and 50 on all 50 devices. Well, before the advent of VTP, you would have to manually log into each switch and execute the command over and over again. Say VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, then go to the next switch and do it all over again. VLAN trunking protocol actually employs a server-client mechanism where if you make one switch VTP server or VLAN trunking protocol server and the rest of your 49 switches as clients, if you create VLAN 10, 20, 30, 40, and 50 on the server switch, the client switch will listen to what the server is doing and automatically create VLANs 10 through 50 for you. So, VTP operates in three modes. The first mode is your VTP server mode. Now, going back just a bit, remember that VLANs on your switch are stored in a file in Flash called VLAN.dat, which holds your VLAN database. So the VTP server mode switch can modify its VLAN.dat file. It is allowed to modify the VLAN.dat file. What does this modification constitute? Well, adding a VLAN is a modification. Deleting a VLAN is a modification. Changing a VLAN's name or assigning it a name from null to something else, like CCNA, is a modification. And changing a VLAN's maximum transmission unit, which by default is 1500 bytes, to something else is a modification. So adding a VLAN, deleting a VLAN, naming a VLAN, changing a VLAN's MTU. So the VTP server mode switch can modify its VLAN.dat file. And these modifications are carried downstream from the server switch in VTP advertisements. The client switch, it's pretty easy to get, will listen to these modifications sent out by the VTP server switch and do accordingly. So if the VTP server switch adds VLAN 10 through 50, the client switches will also add VLANs 10 through 50. The VTP client switch, however, is not allowed to modify its VLAN.dat file. So if I am on a client switch and I try to create a VLAN, or change a VLAN's name, or change a VLAN's MTU, or delete a VLAN, it will actually tell me that it's not allowed. The last mode for VTP is your VTP transparent mode switch. As the name suggests, the VTP transparent mode switch will relay VTP advertisements, as in one port out the other, but it will not apply the modifications carried in the VTP advertisements to itself. So it will not comply with the server switch's demands. So if the server switch creates VLAN 10, 20, 30, the transparent switch will not listen to the VTP advertisements and create VLAN 10, 20, and 30. However, the VTP transparent switch will forward VTP advertisements to downstream clients. The VTP transparent mode switch is, however, allowed to add and delete its own VLANs, change the VLAN MTU, or change the VLAN name. So basically, the transparent mode switch can modify its VLAN.dat file. And for now, this concludes the VTP lecture section, and we'll start with the lab.